Hello friends, welcome to the next series for Introduction to Object-Oriented Programming. The review of the last session, we have seen about the various syntax and semantics and also the basic data types and the control structures. Today we are going to see about the derived and user-defined data types in details. After this session, you will be able to use the derived and defined data types in solving the problems of C++. So, derived data types, as we have already seen, that is arrays, you have functions, we have pointers, we have references and constants. So, constant can act as a derived data type, but basically there are four important things, that is array, function, pointers and references. These are derived data types. Why they are known as derived data type? Because they make the use of fundamental data types to create the derived data type. So, those data types which make the use of fundamental data types to create itself is known as derived data types. So, arrays is the first data type. Array is actually used to store multiple values in one single variable. That means what? These are special variables which holds more than one value at a time. So, for example, in C++, if you want to declare an array, you have to give the type, then that is type means data type, the name of the array and how many elements you are going to store in that array, in that single variable. So, for example, float is a data type, car is a name of the array and it is saying that it is going to store 10 values inside the variable car. An array value is always accessed by referring to an index number. For example, if I want to access elements from 0 to 9, that is 10 elements. So, if I want to access the first element, I will write car of 0 is equal to, and if I want to assign it the value Maruti, I will write car of 0 is equal to Maruti. To access the car of 5 is equal to, suppose I am writing Mercedes. So, that means the sixth element of car array is Mercedes. So, this is how the array can be accessed by using an index number. So, for example, as you are seeing here, we have int, num and num of 6, that is int is the data type, base type of the array, num is the name of the array and 6 is the size of the array, that means how many elements it is stored. And array does what? Is stores all the 6 elements in a continuous memory location of as seen in the figure. So, it is stored as num of 0, num of 1, num of 2, num of 3, 4 and 5. So, how the memory representation is done in case of array? Now, for example, this is a number array of 10 elements and here num of 0 means 39, num of 1 means 56 and so on, where 2000 is the address location of num of 0, 2002 is the address location of num of 1 and so on. Now, if you observe that num of 0 is having its memory location as 2000 and num of 1 is having its memory location as 2002, not 2001. So, why this is happening? Not 2000 to direct 2002, you are starting the next number 1, because actually the total bytes memory bytes which first num of 0 takes is 2 bytes, because it is an integer array. So, if it is a float array, it will take 4 bytes. So, the next num of 1 will have its location at 2004. Here we are having 2002 because num is considered to be an integer array and integer takes 2 bytes. So, each next number will be stored after 2 bytes. So, that is 2000, 2002, 2004 and so on. So, if I say that I want to calculate the size of an array and if I declare int num of 10, then the size of num of 10 will become size of array, that is 10 into size of its basic type, that is if it is an integer it will be 2, that is 20 bytes. So, in all the num of 0 to num of 9 is taking 20 bytes of memory inside the 20 bytes inside the memory. So, valid operations with arrays are bill of 0 is equal to a, that means at the 0th element I am storing the value a inside the first element of Billy. So I can consider here the Billy is an character array. Next, Billy of A is equal to 75. So I am storing 75 value inside Billy. Now this A can be an index number 1 to whatever I want to write. If I have declared A is equal to 6, so it will store the 75 value in the 7th element of Billy. Here Billy of 1 is equal to Billy of A plus 2 means I am storing some of the value of Billy of suppose A is 1, that means 1 plus 2. If A is 1, then it will be 1 plus 2, that is 3. So Billy of 3 value will be stored into B of 1. So second value of B will be same as that of third value of Billy array, and so on. So here if you can see index can be index array, an array can be an index of another array. So as Billy of A. So this is also a valid operation which occurs with array. Now if you see a program without arrays, as an example, if I ask you to calculate the total marks of 5 subjects, so what we have, and then we are writing marks of 1 is equal to 25, marks of 2 is equal to 28, marks of 3. So I am taking 6 marks. Likewise, if I ask you that you have to find the total of 100, total marks of 100 subjects. So for each and every marks, you will have to, each and every subject you will have to take 100 such variables, as seen here, like 6 variables. So what is happening? I am writing marks 1 plus marks 2 plus marks 3 plus marks 4 plus marks 5 and so on. Okay, so result is there, which is calculated in result, and that is displayed. So here it is going to display marks 137 out of 150. Now if I similar consider with an array, if I consider here, instead of taking 6 different variables, I am writing marks as an array which is storing all the 5 different values 25, 28, 30, 28, 26, and then I am taking to access the elements, that is to access the element like 25, 28. If I want to access 30 from marks, I will write it as marks of 2. If I want to access 26, it will be marks of 4, and so on. So here marks of 0, 1, 2, 3, 4 is represented here with result. Marks is equal to marks plus I. If you can see, result is equal to result plus marks of I. So marks of I is saying that I want to access the, if I is going to come from the for loop, if it is 1, then it will be result plus marks of 1. So 0 plus marks of 0, that is 25. Then next time when I is equal to 1, it will be the marks result is 25. So 25 plus marks of 1, that is 28. 25 plus 28, that will become 53, and so on. So accordingly, if you see here the index given as 0, 1, 2, 3, 4, and when I am taking the output, it is the same as that of the previous example. So for a 2D array, you can refer this particular link to go more in details related to arrays. Now let's turn towards pointers. Each variable is actually assigned a memory slot in and the size actually depends on the data type, and what is stored in the particular memory location is the variable's data. So if I say the memory address, suppose if I am having a memory address as 1020, 1024 and 1032 and so on, and as we can see that 100 at 1024 location a value is stored, that is 100. At 1032 location the value stored is 1024, and I am declaring integer a is equal to 100. So 100 is being stored at 1024 location. That means the variable a's value is 100 and its memory location is 1024. So we can actually use the pointer to reference to a memory cell. Like if I am accessing at 1032, if you can see the address of a is stored as 1024, and this 1024 is acting as a pointer which is pointing to the memory location 1024, which is having its value as 100 and which is an integer value. So here variable that points to a memory location is said to be a pointer which holds the address of another variable as seen in the previous slide, and to declare this type of pointer we write data type and asterisk PTR. So for example, if I want a pointer to point to an integer variable, I will write it as integer pointer asterisk PTR. So here asterisk sign is known as a dereferencing operator, which is making the PTR variable to point to an integer variable. So the operators basically used in pointers is dereferencing operator, that is asterisk, and address of operator. This dereferencing operator shows the value of the pointer value where P is pointing, and address shows the value where address of the pointer. Now the pointer assignment can be shown as integer n is equal to 5 and asterisk PTR. So if you can see that n is a variable, simple variable which is having a value 5, whereas PTR is a pointer, again just shown that it is a integer type of pointer. Now we can write is equal to PTR is equal to ampersand n. That means we are storing the address of n into PTR, as PTR is a pointer which holds the address of a variable. So it is storing the address of n variable, and asterisk PTR is equal to 3 means I am assigning the value of where PTR is pointing to 3. That means indirectly I am changing the value of n is equal to 5 to n is equal to 3. So first pointer is known as pointer declaration, and the last two things are known as pointer assignment. Now pointer arithmetic, let's take this example program. Suppose if I am having a of 5, 1, 2, 3, 4, 5, b and asterisk pt. So pt is equal to ampersand a of 0. At this particular point, pt is pointing to the address location x 1000, which is an address location of a of 0. When I am writing pt is equal to pt plus 4, this automatically changes the value of pt to a of 4. So when I am writing pt plus 4, that means I am not incrementing the value by 4, but I am incrementing the address by 4. That is, the pointer will now point to, after this particular thing, will point to 1010 location. And then I am making b is equal to a of 0. That means the value of a of 0 will be given to b, and when I am writing b plus is equal to b 4, it is going to increment the value, that is b is equal to 5. So these two things are different. When I am writing pointer plus 4, it increments the address, and when I am writing simple variable plus 4, it increments the value. That is, as you can see in the above, b's value is becoming 5 and pt's value is becoming x1010. So thank you dear students for listening to the video. We have studied about array and pointers in the same. Waiting for the next video to be uploaded soon. Thank you so much.